This will be the last video of the series of the Exponential Applications series, part 5. And we are discussing half-life. So for half-life, we're going to use the following formula. A of t is equal to P times 0.5 raised to the t divided by h. Notice I highlighted 4 variables. So that's what we're going to be looking for, at least 3 of those within a word problem. And the other one is the one that we're actually trying to find. So A of t, P, this time instead of rate, we have H, which stands for half-life time. And then we still have T for time in years. So pay attention to that. Ayan and Yasir were studying the characteristics of items in chemistry. They noticed the half-life is 15.8 years for platinum when the initial mass is 78. Saida asked them to help her determine how much would remain after 35 years. So first off, I just want to preface this by saying this is not probably accurate information. I was just using numbers for example purposes. So those of you that are in science, I'm just using numbers for just to demonstrate how to substitute this information into a formula. Okay, so what am I looking for? It says how much would remain after. So again, after time, I just look at it as A and T, just happen to start with A and T for after time. And that's like the future value. So how much would remain? That's what we're trying to find out. So that's where we're going to put our question mark. Now, if you're used to word problems, you know specific words to look for, such as is. Is means equal. So they're telling you half-life is 15.8 years. So then all I have to know is which one of the variables represents half-life. And we know it's H. So I'm just going to put 15.8 here. And then it says the initial mass. Well, remember, when you go back to what each variable stands for, one of the key words was initial. Initial is 78. So that is your P. So P is 78. See, is the equal sign. Saida asked them to help her determine how much, that's what we're trying to find in the future, after how many years? 35. So that's the time in years. See, wasn't so bad trying to get the information for the variables. Now all you have to do is take what you have here and place it in the position that's shown in the formula. Make sure you are wherever that variable is located, that's where you're actually substituting the number in. So what I want to do for A of t, since there's a question mark, is just leave it as A of t. That tells me what I'm actually looking for. Instead of P, I am going to replace it with the number 78. P is 78. The formula asks me to multiply it times 0.5 and then raise that value to 35 over 15.8, which is my H, my T and my H, sorry. What you want to do now is go to your calculator. And in your calculator, you are going to just type in what you just said. Let me go back to that screen. I lost it. Okay, so 78 times 0.5, and I'm going to put it in parentheses, 78 times the 0.5 is in parentheses, and the 0.5 is the only part that's raised to this 35 over 15.8. So 35 divided by 15.8. Whenever you see a fraction, that means divide. Whatever this answer is, that is your A of t. So we're going to just round it to the nearest hundredths place. So that 79.7, that 7 is going to make this change. You're going to have to add 1 to it, which in turn will affect this. So it's 16.80. You really could write 16.8, but I'm just going to do 16.80. So for my A of t, my answer is 16.80. Okay, that's all you have to do. So now, if you've been following the videos, you understand I'm going to take the same scenario and I'm going to show you how you would find each of those variables if you were asked to do so. So for the next one, I'm asked to find P. We just said that A of t was 16.8, so I went ahead and just created a list of the variables and what I already know. and I'm asked to find P. So the formula tells me to take A of T and place it to the left of the equal sign. So that's what I'm going to do. 16.80 is equal to P times 0.5 raised to the T over H. And again, I'm getting my data from over here. Wherever I see the variable, I just substitute it in. If I don't see a variable, if there's a question mark, then I just go ahead and use the variable that is shown. In this instance, what I want to do is just simplify my exponent. So the base 0.5 is raised to that 35 over 15.8. So that's what I'm going to put in my calculator. 0.5 is raised to 35 divided by 15.8. So what I'm going to do is instead of writing all of these numbers down, I'm just going to write 4 places after the decimal, and I'm going to round this 3 up to a 4. So 0.2154. 0.2154, but I have a P on this side as well. Set that equal to 16.80. And I have to ask myself, well, what's stopping P from being by itself? And whatever is stopping it, that's what I'm going to divide both sides by. And that's that 0.2154. When I do the math in my calculator, I'm going to take 16.80 divided by, and I can go up and copy the entire number this time, enter, and enter once more. And it says it's 78. So P is 78. But again, I am using the same scenario. So if I go back, I already knew that the initial is 78, and initial means P. So I know I'm on the right track here. The next scenario asked me to find T. So we're just going to, again, use the same formula. I know that I have 16.80, which is my A of T, is equal to P, which is 78, times 0.5. This is just part of the formula. That's always going to be 0.5 when it's half-life. All raised to T over 15.8. And yes, order matters as far as if the 15.8 goes on top or the T goes on top, because the formula says T over H. So I want to take, so this time my exponent is located in my variable is located with my exponent. So whatever is stopping my exponent from being on the side by itself, which means if there's something before or after, I want to get rid of that first. So I want to get rid of this 78 by dividing both sides by 78, because the inverse of multiplying, this is multiplying, and we don't want to do that, is to divide. So go back to the calculator and type in the 16.80 divided by 78, and it's going to give you that same number, 0.2154. So we'll go back and write that, 0.2154. And this is all set equal to 0.5 raised to the T over 15.8. You have 2 options here. What you could do, well, I'll come back to that in the end. I'm just going to show you the way that you would normally do it. What you would do is rewrite this, since this is an exponent, rewrite it as a log. So what I'm going to do is take my exponent's base, 0.5, and I'm going to set it equal. Let me just write it here. So log, whatever my base of my exponent is, that's also the base of my log, which is 0.5. My value is going to be on the opposite side of the equal sign. So it's 0.2154. Make it a habit of putting it in parentheses. And then you want to go back across the equal sign to your exponent and set everything equal to that exponent, which is T over 15.8. So the inverse of division is to multiply. I need to get T by itself, so I'm going to have to multiply both sides by 15.8. So that gets rid of it on that side. And I have to do the exact same thing over here, 15.8 times log. So if I go to my calculator, I'm going to type in 15.8 And then what I notice is my log has a base. So what I need to do, instead of pressing this log button, which tells me that there's a common base of, the log base is 10. I don't want that. I want to go to math, and I can either arrow all the way down to A or just hit alpha, which is green, and then above math, you'll see a green A. That allows me to go ahead and put in a new base, which is 0.5, and then my value is 0.2154. And my answer is 34.99, which I'm going to round to 35. That's how much time that it will take. We already knew that. Again, if I look up here, I already wrote it there. So it's going to be 35. What I was about to say earlier is if you wanted to use the calculator where it is y equals, so y is equal to 16.80 in your table. So after the equal sign, this is what you would put in your calculator. So we're going to go to y equals. Let's clear all that out. And under y equals, we're going to type in 78, all of this, times 0.5. But instead of raising it to the t, we're going to raise it to x because we're using our table, and our table has x and y's, divided by 15.8. Then you want to, like I said, go to your table, which is second table. You go over to y and you're looking for 16.80. Well, if I look here, I see these are huge numbers. So in order to get to 16.80, I already know the answer is going to be 35. So I can just change my table set to, I don't know, let's just say 32. And now when I go over here and I look at 35, it says 16.80, which is what we're looking for. And when it's 16.80 for y, it's 35 for x, and x represents our t in this case. That's one way to do it, or you can just go to this step, and this is the new y equals, meaning this is what you're looking for in the table for y. So let's do that one, clear that out, and we had 0.5 raised to the x over divided by 15.8. Go to our table. And again, I already have it set where it's in the general vicinity. So if I go down to 35, I see y is 0.2154 when x is 35. And again, x represents t. Okay, that's another way that you can do the, try to figure out if you're on the right track. You can verify your answer. And then the last example is now we're trying to find h. We already know a of t comes first, 16.80. P is after the equal sign. The formula tells us to multiply it times 0.5 and then raise it to t, which is 35, over h, which we don't know in this case. Since my variable is with my exponent, I want to get rid of anything in front of it or behind it. So 78 happens to be in front of it. So we're going to go ahead and get rid of that by dividing. And if I go to my calculator, actually, we already did this. So up here, we did these 16.80 divided by 78, and we got 0.2154. So 0.2154 is equal to 0.5 raised to the 35 over h. And now I want to do the same thing with my log, rewrite it. This will be log base 0.5 of 0.2154 is equal to my exponent, 35 over h. And what I'm trying to do here is I'm trying to get h by itself. So same thing, I would multiply, there's another way to do it, but multiply it by h. And then that gets rid of that. And what you're going to do now is you're going to divide what's stopping h from being by itself, which is all of this. So basically, we could have just swapped those two out, but I don't want to confuse you. So I'm showing you step by step what to do. So I'm going to divide both sides by log base 5 of 0.2154. And the same thing over here. Log base 5 of 2154. So even if you have like an expression or something that's long, that's stopping your variable from being by itself, just divide it by all of it. It's fine. So what I'm going to end up with is H is equal to, go to my calculator, type in, well, to get out of here, you go to second mode because above mode says quit. You want to type in 35 divided by, remember, in order to get to your, to be able to change your log base, you have to do math, alpha, math, or math and scroll down to A, 0.5 and 0.2154, I believe. Yes. And my answer here is 15.8. So let's see. For my half-life, 15.8. If I go back up to my scenario, or even here, yes, I see that is correct. So I have demonstrated how to use half-life and how to find each one of the variables. Subscribe and thumbs up. Have a great one.